And our question 2 of this January 2014 CXC CSEC exam video solution. And part 1 gives us this linear inequality to solve for x. We know that this is a linear inequality because the highest power of the variable term in this inequality is x, and the highest power of the x is 1. We only have terms in x, and so it's a linear inequality. And when solving a linear inequality, it is just like solving a linear equation, just that if we have to multiply or divide the inequality by a negative number, we have to remember to reverse the inequality sign. So let's proceed to solving this linear inequality just as we would a linear equation, remembering that if we have to multiply or divide the inequality by a negative number, we have to reverse the inequality sign. Let's proceed. Now firstly, we're going to expand this bracketed term to break the x out of this bracket. So we're going to expand the bracketed term by multiplying the 2 by the x and then multiplying the 2 by the negative 6. And when we do that, we end up with 2x minus 12 plus 3x less than or equal to 8. That is 2 times x is 2x, 2 times negative 6 is negative 12, the plus 3x comes back here, less than or equal to comes back here, and we have 8 on this side. Then what we're going to do next, we're going to add the terms in x. So the 2x and the 3x here will add to 5x. This negative 12x, we can take it on this side and add it. There's no need to reverse the sign because we are not multiplying or dividing by a negative number. Essentially what we are doing is adding 12 to both sides so we can get rid of this negative 12. Let's show that. And this is it. The 2x and the 3x gives us 5x here. The negative 12 comes on this side to become positive 12, or we say we add 12 to both sides, and the adding of 12 on this side will eliminate this negative 12, and then on this side we have 8 plus 12. Now the 8 plus 12 here is 20, and so what we have is 5x less than or equal to 20. Then to make x a subject, we need to divide both sides by 5. And because we are dividing by a positive 5, there is no need to reverse the inequality sign, and so we can proceed to say that x will be less than or equal to 20 divided by 5. And the 20 divided by 5 is 4, and so the result is that x is less than or equal to 4. That's the answer for this inequality. X is less than or equal to 4. Let's move down to part 2. What we have so far is that x is less than or equal to 4, and part 2 is asking us to show this solution on a number line. Now what I'm going to do, I'm going to show the number line solution and then explain why it appears as it does. Now this is our number line, our x-axis, and we have shown the values negative 1, 0, 1, 2, 3, 4. 4 is the point of interest because we want to represent the inequality x less than or equal to 4. So this is our point of interest. Now the x less than or equal to 4 here means that x can take values of 4 or less. And so this is how that would appear on a number line. Let's put in the inequality x less than or equal to 4. Now notice that the shaded circle is placed on the 4. The shaded circle on the 4 means that 4 is included in the inequality and x can take values 4 or less. So because the equal is a part of the inequality, we shade the circle on the 4, and then the arrow pointing to the left means that x can also take values less than 4. So on this side we have values less than 4, and the shaded circle on the 4 means that 4 is also included. Just to emphasize the point, let's show what the number line would be if we had x less than 4. If our number line was for x less than 4, then what we would do is put an unshaded circle on the 4. The unshaded circle on the 4 means that 4 is not a part of the inequality. We only want values that are less than 4. And so since 4 is the boundary value for the inequality, we put an unshaded circle on 4, and the unshaded circle means that 4 is not included. We would only want values that are less than 4, but the circle is placed on the 4 because 4 is our boundary value. It is the boundary value for the inequality, and so this would be the number line if we wanted to represent x less than 4. An unshaded circle on the 4 here, and for x less than or equal to 4 we place a shaded circle on the 4 because the 4 is included in this case. This is the answer for this part of the question, and we showed this just to emphasize the difference between the shaded circle and the unshaded circle. Let's move down now to part B. Part B wants us to factorize this expression. I see 4 terms here, and so I know it's a factorization by parts or a factorization by grouping. So what we'll do, we'll factorize the first 2 terms and then factorize the second 2 terms such that we have a common factor on both sides. So let's go through the steps and show how we can ensure that we proceed smoothly through this factorization. So the highest common factor in the first 2 terms here is 3. So I'm taking out 3 as a common factor. And so when I factorize 3 out of these 2 terms, my result inside the bracket is x minus 2y, because 3x divided by 3 leaves me with x, and then a negative 6y divided by 3 leaves me with negative 2y. And to ensure that we have the same thing in the bracket on this side, what I always tell my students to do is to put back this expression here first. And that is it. We are putting back the x minus 2y in the bracket here first. Then we observe what we would have to factorize out of this positive ax to end up with the x in the bracket here. We would have to factorize then plus a out of this expression to end up with the x inside the bracket here. So let's show that. So that's it. Ax would be our factor out of these 2. And to ensure that the factorization is correct, we would check the expansion now of this expression on this side. And so it is a multiplied by x is ax here, and positive a multiplied by negative 2y is negative 2ay, and so this factorization is correct. And so the bracketed term now becomes our common factor for these 2 terms. The bracketed term, the x minus 2y, is now a common factor, and so it is 3 times this factor plus a times this factor, and so the result is 3 plus a times that factor. And so that's the result of that factorization. Let's move down now to part 2. So part 2 gives us p squared minus 1 to factorize. That's 2 terms, and I see a negative sign, so I'm thinking the difference of 2 squares. And I must remember that 1 is a perfect square. It is very important to remember that 1 is a perfect square. It is a perfect square of 1. And so this can be expressed as a difference of 2 squares. That is p squared minus 1 squared. And just to remind us of the rule for the difference of 2 squares, this is it. A squared minus b squared is equal to a minus b multiplied by a plus b. That's the difference of the 2 numbers multiplied by the sum of the 2 numbers. That's the rule for the difference of 2 squares. And so if we apply that rule here, our result is p minus 1 multiplied by p plus 1. And so that's the result for the factorization of p squared minus 1. That is p minus 1 multiplied by p plus 1. That's the answer for that part. Let's move down to question 2c. Now question 2c wants us to expand and simplify this expression. Firstly, we're going to multiply this 2k by each term in this bracket, and then we're going to multiply the negative 3 by each term in this bracket. That's how the expansion will be done. Let's show it step by step. And so firstly, we'll multiply the 2k by the k here, and the result of that is 2k squared. And then we'll multiply the 2k by the negative 2. Let's show that. We multiply the 2k by the negative 2, and 2k multiplied by negative 2 is negative 4k. And then we'll multiply the negative 3 here by k. Let's show that multiplication on here. And that's it. Negative 3 multiplied by k. Let's show that result. That's negative 3k. And then negative 3 multiplied by a negative 2 is positive 6. We have to remember to carry the sign, and so it is negative 3 multiplied by a negative 2. And so the result there is negative 3 multiplied by a negative 2. The result is a positive 6. And then we can simplify this expression. 2k squared stands by itself. There are no like terms. 2k squared, so that stays by itself. The negative 4k and the negative 3k will give us negative 7k, and then the constant term will remain positive 6. And so the result is 2k squared. Negative 4k and negative 3k gives us negative 7k, and then we have plus 6 coming back here. And that's the answer for this part, question 2c. Let's move down now to part D. Now part D wants us to show that this point, 1, negative 1, is the point of intersection of these two lines. Now what we can do, we can solve the equation simultaneously, these two equations simultaneously, and show that this is the result. Because when we solve equations simultaneously, we actually are finding the point of intersection of the two lines. And so we can do this by solving the equations simultaneously. Let's proceed with that method, and then I'll show you another way that it could be done. So let's go. So firstly, we're going to do it by solving the equations simultaneously. So we're going to call the equations equation 1 and equation 2. And we're going to solve them by the method of elimination. And since I see a negative 2y here and I see a plus y here, I can adjust this equation by multiplying it by 2. So we will have a positive 2y in the first equation. So that's what I'm going to do. I'm going to multiply the first equation by 2 to create a positive 2y, so I can eliminate the y from the two equations. And when I multiply this first equation by 2, I multiply each term by 2. And 3x multiplied by 2 is 6x. The y here multiplied by 2 is 2y. And the 2 on this side multiplied by 2 is 4. So when I multiply this equation 1 by 2, this is the result. The equation 2, I'm going to keep it as is. And so it comes back as 4x minus 2y equals 6. That's 4x minus 2y equals 6. And now I'm going to call this first equation 1 prime because it was derived from equation 1. It is really the same equation but just adjusted by multiplying by 2. And then this equation 2 comes back as is. And now if I add the two equations, I will eliminate the 2y terms because this 2y will eliminate this negative 2y. And so I'm going to add two equations, these two equations, in order to eliminate the term in y. And so I'll find x value first. When I add the two equations, I have 6x plus 4x is 10x. The terms in y are eliminated when I add them, and then 4 plus 6 is 10. And so if 10x is equal to 10, then it means that x must be 1 because 10 multiplied by 1 is 10. And so now to find the corresponding value of y that goes with x equals 1, we substitute x equals 1 in equation 1, or we can use equation 2. It's easier in this case to use equation 1, and so we're going to substitute x equals 1 in equation 1 to find the y value that goes with x equals 1, and this is it. 3 times x becomes 3 times 1 because x is 1 plus y, that's plus y, and the result here is 2. And so that's 3 times 1 plus y equals 2. And so 3 times 1 is 3. And so to make y the subject, we're going to subtract the 3. And so y is going to be 2 minus 3. Right? And let's show that. 2 minus 3 is negative 1. And so the y value is negative 1. And hence, we have shown that the point 1, negative 1, x value of 1, and a y value of negative 1. And so we have shown that the point 1, negative 1 is actually the point of intersection of these two lines. But we could have also shown that this point is a point of intersection of these two lines by showing that the point satisfies the two equations. And let's do that here. And that might be a quicker way to do this solution, by showing that the point 1, negative 1 satisfies the two equations, And we do that by substituting the value x equals 1 and y equals -1 into the equation to show that the results are the same as represented in the equations. Let's do the first one. In the first one, if we substitute 1 for x and -1 for y, we would have 3 times 1 plus -1. 3 times 1 is 3 plus y is -1. So this really is 3 plus a -1, or we can say 3 minus 1. 3 minus 1 is 2, and so that is satisfying the equation. This point is satisfying the equation, first equation. And let's show now that it also satisfies the second equation by substituting x equals 1 and y equals -1 into the second equation. When we do that, we will end up with this. 4 times 1, because x is 1, minus, this minus here, 2 times y is -1, so it's 2 times -1. That is, when we substitute x equals 1 and y equals -1 in the second equation, the left hand side becomes 4 times 1 minus 2 times -1. 4 times 1 is 4 here. -2 multiplied by -1 is +2. So we really have 4 plus 2. 4 plus 2 is 6. And so that's it. The point satisfies the second equation as well. And so since it satisfies both equations, it means that the point 1, -1 is the point of intersection of the two lines. And that's another way you could have shown that this is a point of intersection of these two lines. And so that's the answer for question 2D and the end of question 2. And we'll do question 3 in the next video. See you then.